Hi, you are welcome to this channel. In this video, we'll be learning how to convert binary to hexadecimal. So from the example on the screen, we have to convert 110111011011 base 2 to hexadecimal. Now, if you are given a question like this is what you are supposed to do first. Now, rewrite all the bits, making sure that you can regroup them into 4 sets. So let's begin. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So currently I have 12 bits on my screen, which can be grouped exactly into groups of 4. Right, so let's begin by doing that. So this is 1 1 0 1, the first group, 1 0 1 0, the second group, and then 1 0 1 1 being my third group. Now to do that, let's apply the positional notation to each and every group to get our answers. Now to do that, the number of bits in each group is 4, so we open that same number of brackets. So let's add our figures 1 1 0 1, which is the first group, times the base, which is 2, times 2 times 2 times 2 raised to the power 0 1 2 3. Any number raised to the power 0 is 1 1 1 1, plus any number raised to the power 1 is the same number times 0 amount to 0, so we cross it. Any number raised to the power 2 is that number times itself, so 2 times 2 gives us 4 times 1, which is the same number 4. 2 raised to the power 3 is 2 times 2 times 2, which is 8, times 1 gives us what? 8. Now by adding this, we get 8 plus 4 gives us 12 plus 1, which is 13. Let's put it here. Now let's take the second group and apply the same positional notation to it. So we open the same number of brackets, addition in between. So in the second group, we have 1 0 1 0 times the base. Now each base raised to the power 0 1 2 3. So any number raised to the power 0 times 0 gives us 0. This also will amount to 0, so let's cross them out and work with the ones that will get a value. All right, 2 raised to the power 1 is the same number, 2 1 2. Now 2 raised to the power 3 is 8, 8 1 8. Now if we add this, we are going to get 10, right? So this is 10 base 10. This is 10 base 10. Now let's take the third group, apply the same theory to it. So in the third group, we have 1 0 1 1 times the base. We have 0 1 2 3. Any number raised to the power 0 is 1 1 1 1. Any number raised to the power 1 is the same number, 2 1 2. Now this will amount to 0 because it's multiplying 0. 2 raised to the power 3 is 8, 8 1 8. Now by adding this, we are going to get 11 base 10. Now let's convert this to base 16. In doing that, we are supposed to assign their base 16 equivalent values to them. Now let's rewrite all of them. We have 13, we have 10, and then 11. These are in decimals. Now 13 in hexadecimal is D, 10 in hexadecimal is A, 11 in hexadecimal is B. So therefore the equivalent value for 110110101011 base 2 is equal to DAB base 16. In the next example, we'll be converting 1001101 to hexadecimal. Now, we are supposed to make sure that we can group them into fours. If not, we add a leading zero to amount to the groups of 4. So, let's do it this way. Now, let's count the number of bits available in our given digits. So, we have 1, 2, 3, 4, 5, 6, 7. When we group this, we won't get 4 groups. So, we need to add a leading zero. We need to rewrite it and add a leading zero. So, it's going to be 1001101, then we add a leading zero to get the groups of 4. So by adding the leading zero, we get 0100 as the first group and then 1101 as the next group. Now let's apply the positional notation. Let's pick the first group. So it's going to be, we have 4 bits in each group, so you open that same number of brackets. So we have 0100. Now times 2 times 2 times 2 times 2 raised to the power there. 1, 2, 3. Now this will give us 0, this will give us 0, this will give us 0, but this will give us what? 4, right? So in the next group, we apply the same positional notation. So we have 4 bits, open that same number of brackets, addition. Now we have 1101 times the base raised to the power 0, 1, 2, 3. Now the ones multiplying 0, you cross it out because it will amount to 0. Now 2 raised to the power 0 is 1, 1, 1, 1. 2 raised to the power 2 is 4, 4, 1, 4. 2 raised to the power 3 is 8, 8, 1, 8. Now we add all of them, we are going to get exactly 13, right? Now so this is in base 10, take note of that. Now let's represent them in their equivalent value in base 16. So the first one is 4 in base 16 is the same 4, but now 13 in base 16 is D. So therefore the answer is equal to 4D base 16. Alright, let's take a look at the last example. Now let's convert 101010 to hexadecimal. Now let's rewrite them, making sure that we can group them into 4 bits, right? So in rewriting this, we get 101010, which is 6 bits. So we need to add a leading 2 zeros to make it groups of 4 so that we can get the groups of 4, right? Or the 4 groupings that we want, right? So we have 1, 2, 3, 4 now, another 1, 2, 3, 4. So these are 2 groups. Now let's apply the positional notation. So open the number of brackets according to the number of bits in the first group. So we have 4 bits, that same number of brackets. So we have 0, 0, 1, 0 times the base raised to the power 0, 1, 2, 3. This will give us 0, this will give us 0, this will give us 0. Now 2 raised to the power 1 is the same 2, 1, 2. So the answer for this place is 2 base 10. Now let's take the second group and apply the same positional notation. So it's going to be, we open the same number of brackets. So the second group we have 1 0 1 0 times the base raised to the power 0 1 2 3. This will give us 0, this will give us 0. So 2 raised to the power 1, 2 raised to the power 1 will give us 2, 2 1 2. 2 raised to the power 3 will give us 8, 8 1 8. So the answer is equal to 10. Now let's use the hexadecimal system to find their equivalent hexadecimal numbers. So by rewriting, or we get 2 and then 10. 2 in decimal, 2 in hexadecimal is the same 2. But now 10 in hexadecimal is A. So therefore, the equivalent value for 101010 in hexadecimal is equal to 2A base 16.